Hello everybody, and welcome to all our viewers worldwide that today gathered to listen to our live market briefing, RF front-end market evolution in mobile phones, powered by YOL Group. I am Faisal El-Kamasi, Senior Global Sales Support Manager for YOL Group, and I will guide you during this webinar. This live market briefing will provide insights into these topics based on YOL intelligence reports and the new quarterly market monitor, which tracks market size all the way down to wafer level, as well as supply chain, market share, and technology evolution. To do so, I would like to introduce you how two speakers, an expert from the RF device and technology team in Power and Wireless Division, Cedric Malakin, Team Lead Analyst, and Noor Popov, Technology and Market Analyst, both from YOL Intelligence, part of YOL Group. Before we get started, I encourage you to submit your question to our analysts during all the live events. Using the Q&A section windows at the bottom of the screen, question will be answered right after the presentation. In case we don't have time to answer all of them, we will follow up with you by email. So let's start the live market briefing. Cedric, Noor, the floor is yours.
Thank you.
Thank you, Faisal, for the introduction. So we are there today, glad to present you our brand new product, which is the smartphone RF market monitor. Just introducing through a few principles the way we depict this market. We are using an end-to-end approach, which we believe is really accurate. We are using insight from YOL System Plus regarding the RF front-end architecture analysis, cost estimation, selling prices. We have access to technology and process and die size. And with that, we are injecting some data into our model, doing top-down and then doing bottom-up analysis. We are analyzing the quarterly earnings calls from the different stakeholders. We are performing interviews with industry players, and we are attending conference. So with that, we are ending up with a product which gives access to the market size, component units, and wafer forecast. So again, looking at the market segmentation, so we have a quarterly focus. We are looking, as I said earlier, market size, market share, component unit forecast, and wafer level forecast. We are segmenting the product each quarter, having a focus. So first quarter, we are looking at the cellular connectivity, meaning 2G from 5G, sorry. We are looking at the component detail, baseband, transceivers, RF front-end modules, RF component discretes. Then we are looking into emerging technologies such as millimeter wave, non-terrestrial network access, or non-connected devices. For instance, a device such as the transceivers inside this segment. The third segment is the geolocation, in which we are tracking GNSS evolution and ultra-wideband as well. And the last segment, we'll dig into the Wi-Fi technology, going from Wi-Fi 4 all the way up to Wi-Fi 6, Wi-Fi 6E, and forthcoming Wi-Fi 7.
Okay, so let's start by the market trends. So first of all, we'd like to go through the evolution of the smartphone volumes. So here we have some data from last year and updated for this year. So actually last year we have anticipated the recovery of the market after the COVID-19 with the different lockdowns, followed by inventory correction phase in 2022. Now, if we look at our data in 2022, actually our numbers were lower than our expectation because last year we had some shortage in semiconductor components. Also in 2022, also this inventory correction phase has been exacerbated by some external factors. So the geopolitical tensions, the war in Ukraine, tensions in Taiwan, and also we have also the inflation, which is continuing, and the policy of zero COVID in China, which is continuing. So another strong trend in the market was regarding the 5G expansion. So actually, the mobile data traffic, as you can see in this graphic, is increasing exponentially. The 5G data will represent a substantial percentage from the mobile data by end of 2027. It's also important to look into the 5G penetration. We have here two word maps showing the 5G footprint and the 5G standalone footprint. So 5G is here in the main markets in North of America, in Western Europe, in China, and Asia Pacific region. In India here, actually it's in blue, but what happened is that the market has opened very recently in summer 2022, and it's going very fast. Another thing is regarding the standalone. So this is also gaining momentum actually. And we can see that the standalone markets, networks, they are ramping up with a presence within 16 countries, and we expect standalone to go for private networks, for instance. Also, it's important that we talk about the mobile network operators. So as you can see in this graphic, their number is increasing, the operators which are investing in 5G. These mobile network operators are actually the main drivers for 5G. It is also important to talk about the use cases. What will attract the customers to this 5G? So let's start by the ultra wideband. So this technology actually is a 20 years old technology. Today, it has been reborn as a precise, secure, real-time technology for positioning in the centimeter range. It can operate with line of sight up to 200 millimeter under the ideal conditions. In that sense, so it's opening some new use cases. So we have the file sharing, point to share. We have the augmented reality, because this technology is very precise in terms of ranging and positioning. We have also a finite device. So it's, for example, with the AirTags developed by Apple, but also the smart tags from Samsung. We have smart remote control as the solution that has been launched by 7Hugs. And we think that ultra wideband will continue for mobile home application. Let's move now to the 5G. One big trend is the 5G stadium. We see tens and tens of stadiums equipped with 5G, and actually it will provide the 5G network with its reliability, with its capacity, but also some mobile network operators, for instance, Verizon in US, during the Super Bowl has provided some immersive experiences with 5G. Also, 5G is for AR and VR. These areas are increasing, and they are in tension, and they are benefiting from progress in the different displays and 3D algorithm, 3D compression algorithm. So we have mobile networks that are promoting their 5G networks by streaming AR, concerts, and movies. Also, cloud gaming, which is also increasing the 5G, will provide reliability and also reduced latency, which can be very interesting for the cloud gamers. And finally, for the 5G, we have the 5G holographic call. So this application has been demonstrated during the last MWC in Barcelona these last 2 years, and there is a big enthusiasm regarding this application. We have some mobile network operators that are providing, that are showcasing, multiple holographic calls during TV shows to push the customers towards these 5G holographic calls. And finally, to finish, so we have the GNSS, the advanced GNSS technology, some use cases such as the AR navigation solution and the GNSS Smart City. Let's now have a look at the 5G rollout. So here we are showing the regional repartition. so the regional penetration actually of the 5G into the smartphones and into the infrastructure. So what we can say here is that we have the leadership with North of America, with China. So we have approximately 90% of devices that are 5G capable, and also in terms of infrastructure, it's well advanced. Then in Europe, so we're trying also to catch up, but we're still late in terms of infrastructure. And after, so we will have the Asia-Pacific region, followed by Africa and the Caribbean and Latin America. So we are very late. And 3G and 4G will remain the dominant air standards.
Okay, so the smartphone market is down in 2022, that's one thing. But the good news is there is a lot of advanced wireless technology progressing. Looking at the different charts that we have here, so we have been putting the 5G penetration rate in 2022. So there is a huge leap forward in 2021 already, continuing into 2022. And there will be an evolution of 5G penetration toward 2027 because of the take rate of the technology that is progressing. Millimeter wave is also part of it, but it's more take more times to take over, remain at the moment still limited to some countries, some markets, but we believe there is strong potential in the technology and we take over from 2027 onward. Looking at the Wi-Fi, there is also a strong take rate of Wi-Fi 6 that started back in 2019. The technology is really popular into smartphones. It's not taken as much as the 5G is penetrating the smartphone, but still it's giving a lot of bill of material into the smartphones that is helping the market to grow. Looking also ultra-wideband technology, so we see the technology that is penetrating into the flagship or premium phones at first. It will penetrate the mid-tier as well in the near term. The thing is there is an enlarging ecosystem with especially Android that now has joined iOS from Apple and also the OEM initiative that are pulling this technology. And GNSS upgrade is the last thing that we want to highlight here. With new satellite generation programs such as Galileo or GPS-3 that will increase the precision, the accuracy of a smartphone in terms of geolocation. Okay, now going into the technology itself, how we convert it into the market. So as we already said, we are using Your System Plus insights. Your System Plus is producing 50+ teardown a year. Via the front-end architecture analysis, the component cost breakdown, which is really useful to analyze this market. So we are modeling that, tuning through the earning call analysis and interviews feedback that we are gathering. If you look at the middle chart, what we see is the bill of material per air standard. So it's giving the cellular technology, 4G, 5G, 5G with millimeter wave, and the Wi-Fi standards, so Wi-Fi 4, 5, 6, and 60. And it's broken down into the different smartphone tiers, so from entry level all the way to premium. But we can clearly see that the bill of material is increasing when we switch from one technology to another, and when we also grow into the market segment. So the result of that and the penetration of the technology makes the market grow. In 2021, there had been a huge impact on the market that benefited to the whole industry. Main market was for the cellular connectivity. It's the blue bar that you are seeing. Millimeter wave is still rather small right now, but given the number of units, it's a market that is interesting. And for connectivity, meaning Wi-Fi and Bluetooth, it's already a great portion of the market. Geolocation is rather small at the moment. We believe it will grow over the next few years. The RF component market outlook is really positive moving forward, even though the smartphone market is kind of stable right now. Okay, Going inside the technology itself, so we just mentioned the market size. Now we want to highlight and emphasize the product capability to go into the component forecast. So we do two things. We go sizing the component market at board level. So we identify the component functions via RF front-end architecture and how it is evolving, or we put hypotheses on how it will evolve. We apply the segmentation per OEM and phone classes, and with that we output component baseline and forecast with that. And we can provide quarter-to-quarter variation according to seasonality effects. So you see here an example of the cellular front-end components. So it's giving the modules, PA modules, front-end modules for MIMO or diversity modules, and discrete components such as filters and NA switches, power management ICs are also included. And down into the supply chain, we go at the die level. So inside the package, inside the discrete, we analyze through the floor plan layout of the components, also cross section of the component. We have access to the technology breakdown and the substrate, the wafer being used. So gallium arsenide or SiGe, for instance, FSOI, FBAR technologies. So all the technology required to do RF components operating. So this is giving access also to the component breakdown evolution. And even going further, we have access with the die size of different components, the different technology. We can provide such as information such as the die size per technology breakdown. You have the example on the bottom left chart of gallium arsenide cumulative surface per air standard and per market segment, and directly the impact on the middle chart into the cellular PA wafer start forecast. So again, you can see a strong increase in 2021. This is strongly related to the 5G penetration that make the number of wafers started grow, and then you have a projection moving forward. And looking at the overall exercise, so we have access to the data for all of the technology, all of the components and market segments. We can aggregate everything. And you have this here view, quarter over quarter of the wafer start evolution for the different market segments. So talking a bit about the RF component ecosystem. So this is quite a complex ecosystem with many players. So not all of them are depicted on this chart. But basically what we wanted to emphasize here, you have two basically business models. So one is the IDM type companies, companies providing the design and the manufacturing of the components internally. Mentioning, for instance, Corvo or Murata and Skyworks. They are doing the design for their PA and their filters, manufacturing internally, and doing also the module and packaging themselves to sell to the customers either module components or discrete components. Then you have another business model which is also quite populated here on this chart. This is the fabless or fab-lite model. The stakeholder is then doing the design of the different components, so PA, LNA switches, tuners, and filters. Also system on chips are following this business model, and it's then taken to the foundry level, either compound semi foundries for PA, gallium arsenide components, silicon foundries for any LNA switch, tuner, or even system on chip components being manufactured by this company. And specialty foundries, this is basically the foundries that are building, for instance, filter product based on special materials such as lithium tantalite or lithium niobate products. Then it's given to the OSAT companies such as AEC, MCOR, GCET, and others. That gives the product back to the fabless company for them to sell to the OEM. So you have module and discrete in this business model as well. So leading us to the RF component market share. So we have here depicted the component market share. So it's the board level component market share for Q2 2022. It's out of our smartphone monitor Q2 2022. We have an overall market of almost 6 billion in Q2 2022, most of it being inside the cellular RF front end. Then you have a great part of it for the Wi-Fi connectivity, 1.6 billion, including the system on chip, by the way, and millimeter wave, 267 million in Q2 2022. So this is including the interfrequency transceivers and antenna in package front-end modules. And geolocation is still rather small, including as well the GNSS ultra-wideband SOCs. Looking at the balanced leadership inside, you have a top 5 that is foreseeable, that has around 90% of the market. So Qualcomm is first in cellular RF front-end and millimeter wave in Q2 2022, with Broadcom being first in Wi-Fi and number 2 in cellular front-end. Qorvo and Skyward are sharing third and fourth position in cellular RF front-end, and they are growing their footprint in Wi-Fi connectivity with new front-end modules that are being taken more and more by the OEM. And Murata is coming fourth in cellular RF front-end, while is second in Wi-Fi. And then you also have chipset corporation that start to have a piece of the RF front-end market. Mentioning, for instance, MediaTek, we are accounting one chip PA front-end module inside this MediaTek section, just to explain the number. And we have outsider, as we call it, coming very close and growing year over year. For instance, Maxent, which is a Chinese fabless company, and that has moved recently to a fab-lite model that is taking more and more share on discrete business and also on the RF front-end module business.
Okay, let's move now to the technology trends. So the first one is regarding the different releases for the standards regarding all these wireless technologies. So first, regarding the cellular, so we have the 3GPP release 17 and the release 18 that will be closed next year. Actually, the release 17 is building on the previous releases, and it is expanding the 5G ecosystem. This is by the support to NTN, non-terrestrial network, and also IoT. Whereas for the release 18, it is bringing the 5G advanced, so this will enhance the proliferation of 5G across multiple devices and across different verticals. It is also introducing the AI and the ML. In parallel here, you can see that the 6G is still under development. The commercialization will not happen before end of 2013, but the concept is there. We know that the 6G will bring a new foundation, which is the wireless sensing. Now let's move to the Wi-Fi. So the Wi-Fi is based on the standard IEEE 802.11. We have here, so the Wi-Fi 6, so with multiple features. You have the downlink multi-user MIMO. We have the OFDMA, the transmit beamforming for a higher data rate at a longer range. We have a higher bandwidth, so we can support until to up to 160 megahertz. We have also as a feature target wake time, which will save battery life, and this is very suitable for the IoT. The BSS coloring that will make the devices recognize if the incoming traffic is coming from an adjacent network or not, and take measures to optimize the intra-network activity. We have 8 special streams and 1024 QAM. So the Wi-Fi 6E versus Wi-Fi 6 will expand to the band 6 gigahertz, and then we will have the Wi-Fi 7 that will come later with expanding the bandwidth and modulation order. Then finally we have the ultra wideband. So it is also building on IEEE foundation. The standard is 802.15.4 for Z. So as you can see here, it is operating in different portions of the spectrum. But for the mobile, it is in channel 5 and in channel 12. And also, what is important to say is that the bandwidth here is, we have more than 500 megahertz of bandwidth for each channel. Okay. Let's now move to the spectrum. So with all these wireless technologies, the question is how it is managed by the spectrum. So here we have in this slide the status of the spectrum today with respect to wireless technologies. We are also showing the regional repartition of the spectrum. So what to say is that some years ago, the spectrum was assigned to 4G LTE, to Wi-Fi 4 and Wi-Fi 5. And also to GNSS. When 5G arrived, it has reframed the existing LTE bands, but also expanded to the ultra-high band. You can, for instance, you have the popular bands, the N77 and N78. In China, it is N79. China has also the bands N102 and 104. There is a focus on this sub-7 gigahertz band. All actors also are there, even if the US is a little bit late on this sub-7 gigahertz. But also with respect to the latest release of 5G, the 5G expanding also in FR2, so in the millimeter wave portion of spectrum, that has been released up to 72 gigahertz. So here we have the US, we have Korea, Japan that are pioneers in this millimeter wave. Europe is catching up. So this millimeter wave is also important because it will also offload also the traffic for the 5G in denser areas, but also we can have new technologies such as the contactless device that is operating at 60 gigahertz. And then we have between the 7 gigahertz and 20 gigahertz, we have the FR3. So this is for SATCOM services. And finally, we have the FR4, which is beyond 92 gigahertz for the sub-terahertz frequencies, opening new capabilities for wireless sensing for 6G. Okay, so now with this multitude of wireless technologies, with these new bands, we are actually increasing the complexity in wireless technology because from one side, we have high capacity and unstoppable data rates with a new spectrum, with more and more carrier aggregation combinations to support dual connectivity and Wi-Fi cellular interworking. From the other side, we have also new services and protocols. We have the improved geolocation, the NTN with satellite support, and the new technologies such as the connector-less connectivity. So this is also posing new technical challenges, and especially at the smartphone, because we have, of course, a limited space. We have to take care of linearity, coexistence issues. We have also efficiency issues, power consumption, wideband operation, weak radio link budget, and cost efficiency. So to illustrate that, let's compare the bill of material for one premium smartphone. So here we are looking into the cellular and the Wi-Fi. For the cellular, we're comparing the 4G versus 5G. So we can see that the number of components and modules for RF front-end is increasing, especially for filters, tuners, as we are introducing a higher number of bands. But also we have the diversity modules that are also increasing because we have a high number of RX channels with the 5G. The number of switches as well, because the routing of the signal is also more complex in 5G. Regarding the Wi-Fi, so we are comparing Wi-Fi 5 versus Wi-Fi 6. So it is the number of filters which is increasing and the front-end modules. So we have a much complex bill of material, and this translates also into a much expensive bill of material. Okay, so now let's go from the system level to the component technology. So on this graphic, we are highlighting the different radios that a smartphone should support. So this can become actually very challenging because we have a limited number of antennas. We have a limited space for antennas. And for instance, for example, for foldable phones, this will be much more difficult because we have to manage the antenna detuning cases. What we can say is that from system level, all these radios, 5G, Wi-Fi, GNSS, on top of the new mechanisms of MIMO, of higher number of carrier aggregation combination that will induce a better antenna sharing and coexistence scenarios. So this is, for example, by using the antenna plexing. And all these new features that are introduced by the 5G will have a strong impact on the design and on the technology for the different components. So for instance, we have to increase the power level. So today we have moved to power class 2. So with 26 dBm at the antenna port, and we can also go to power class 1.5. The components should operate at a wider band. So it is 100 megahertz of bandwidth. We have also to support the dual connectivity and also a higher number of carrier aggregation combination. So we are showing here some components, but what is important to say is that the challenge is that we have a fixed budget of size, of cost, and of power consumption. We put here, for example, we can take, just to mention, the power amplifier in terms of design. So it should come with a multi-channel, multi-band, support plus 3 dB linear, with from 8 to 10 dB backoff and uplink MIMO. If we take an example of the filter, it should also support the multi-band, steep rejection, low insertion loss, and thermal compensation. At the bottom here, we have put the different technology platforms that are appropriate for each type of component. So let's now move to the portfolio of the technology for all these components. So I can just summarize to say that for a power amplifier, so the mainstream technology today is the gallium arsenide, HBT or BHEMT. That will be the key technology in 5G for this component because of high efficiency, low and high linearity, and also for the output power and low leakage. For the LNA, so there is a trend moving to the RFFE because of its capability of integration and large manufacturability. And this will also enable the integration with the switch. The SiGe by CMOS remains also a very interesting technology as it is offering premium performances. RFFE also is for switch and tuner. It's a mainstream technology with CMOS as an option. We saw recently also MEMS coming to the market with Corvo and some emerging technologies for switches that could be the polysilicon or PCM. For the filters, so we will continue with the SAW filter, which are mature, but we have also derivatives such as the multi-layer SAW and also the TC SAW that are offering better performances. We have the BO filter also with multiple derivatives, and we can support the higher frequencies. And then IPD and MLC that offer a low-cost approach for filter with good enough performance. So here at the bottom, so we are putting for each component, we are summarizing all these technology platforms, and also we are analyzing the different players that are there.
Okay, so just summarizing all the products that we have and that we have been using for doing this webcast, we have taken data out from the smartphone RF market monitor. So we have up to Q3 2022. The RF front-end mobile for 2022 is currently ongoing into production. And then you have a bunch of System Plus products that are really of interest for tracking the wireless connectivity in smartphones. And thank you for your attention.
Thank you.
And we open now for Q&A.
Thank you very much, Cedric. Thank you, Noor, for your great presentation. We received many questions about it in the live Q&A box that we are about to answer now. So let's maybe see this first question. Do you see millimeter wave becoming a greater piece of 5G?
Okay, I can take this question. So yes, so mainly in North America, which is now looking on the C-band. We see also attraction on the FWA, the fixed wire access, in the US also coming strongly. But in other countries, we see more focus on the sub 7 gigahertz spectrum, actually.
I would, I agree. I would maybe add you have initiative toward India to getting the spectrum. We don't see this technology being used, for instance, in China. That's not where we would see it being employed. And another thing is maybe this millimeter wave spectrum is not that much popular in certain countries, sometimes given for free, to facilitate the rollout and the investment in the equipment. So this is kind of incentive for the MNO to kind of roll out the service. So we believe this might be also helpful, this kind of public policy to drive the development into this technology.
Okay, thank you. Okay, and to complete, another question was, do you think millimeter wave will deploy in the other, like North America? So you said yes, but Korea and Japan, and if so, when? You mentioned Korea and Japan.
Korea and Japan, so it's already the case. Japan is already live, so from the beginning, 2020, say. Korea is more a question mark. They have the spectrum. They are kind of using it right now for the commercial use cases rather than for the consumer use cases. It might come, I think, in the next few years. Beyond that, as I said, we believe India is promising. That's a country where people are like connectivity. They are really using phones. They don't have really broadband access at home. So it's really the broadband access is through the smartphone and again in mobility. So there millimeter wave makes sense for that particular country, I think. And it's a great market. Certainly can be the size of the China market.
Okay, thank you. Another question, do you see any disruption coming on RF front-end architectures?
That's a great question. I think you will have more evolution in this RF front-end market rather than disruption. So stepping back maybe into the digital and analog. Digital means you have a lot computing requirement as you need to do more carrier aggregation, MIMO, you need to accommodate NRDC, many different features that we have been seen during the presentation. So it's driving advanced silicon integration and also for the analog part, because of you need low power consumption in the meantime. For the RF front-end side, you don't have much pressure on the scaling, but you need to have a strong pressure on the in-module integration. You have many more components, more routing for the switches, more filters, PAs, LNAs, and so on. So you cannot afford putting that much components without integrating to the modules and make the life more simple for the OEM and also the performance improving. So this is, I guess this is one. And certainly beside that, you have emerging technology or promising technology that can help optimizing the performance of the components, so delivering the right power level, the right linearity to the right cost. So this is where, for instance, we see MEMS tuning as a promising technology for new use cases of antenna tuners being broadband, having a good efficiency all the way to the tuning range. Millimeter wave maybe is a different story. Millimeter wave, you need a lot more integration. And then we think this CMOS approach or FDSOI is also another path toward millimeter wave will be developed in the future. And still there are questions about how to integrate all these heterogeneous components into the modules. Will it be 2.5D, 3D integration? So all those questions remains open. That's where we think the most interesting development are.
Okay, interesting, thank you. One more question. What are your smartphone shipment forecasts for 2023, 2024? It's a tough question.
It's a tough question, great question. There is some uncertainty in the market at the moment. We believe 2023 will be the same way than 2022. We don't expect really an uptake of the market. Difficulties in the supply chain will continue, and also the inflation concern will limit the people willingness to renew their smartphone or to purchase a new one. So we believe this will be not that high, maybe 1.3 billion maximum for 2023. 2024, we think we will have the capacity installation being done and operating. So the supply chain issue will no longer be an issue from that time frame. And hopefully the inflation will have been fixed by the central bank initiative to contain the inflation going on. So certainly a positive outlook for 2024.
Thank you. Maybe we have time for a last question. What is the impact of NTN support being part of 5G release 17?
Okay, do you want to take it?
Yes, maybe I can start. So maybe, yes, so actually it is, yes, the NTN came into the release 17 and it has been used for a critical mission. So it is using the LEO satellite constellation. So what we can say is that most of the innovation for the NTN is regarding the satellite with the large phased array. And also from the devices point of view, so there is also an advancement and a progress for the algorithm which is in the baseband. From the RF front end point of view, so we expect a dedicated antenna so to manage these new bands introduced by NTN, and also dedicated front end module. So maybe yes, we can have more details. Yes, among the latest models of the iPhones, the iPhone 14, for instance, which is supporting the NTN.
Thank you for your very clear answer. Thank you very much. The live market briefing is now ending. Thank you again to our speakers for your time and analysis. Please let me remind you that you can find all our reports and monitors on our website, www.yolgroup.com. Do not forget to create your account to be informed of our latest news. To everyone, you will soon receive an email with the link to the presentation within 24 hours. Do not hesitate to contact us if you have additional questions. Thank you all for joining us today. Have a good day and take care.